So welcome everyone. I will talk about the risk of bias instrument for use in systematic reviews of randomized controlled trials, in short, robust RCT. So in the next 25 minutes or so, I will talk about our rationale to develop robust RCT, then shortly describe the instrument development and give you an overview of the instrument items and its structure. I have no conflicts of interest to declare, really. I'm just very grateful to Ying Wang for sharing slides with me. So the work I'm presenting is the work of the Robust RCT Working Group, and Ying Wang basically did her PhD on this topic. So what drove us to develop robust RCT? I mean, you all know that risk of bias assessment is an essential step in the systematic review process. However, I mean, we did a systematic survey at some point on risk of bias tools that have been developed in the last 10 years. And we see there that the tools have become more and more complex. And so there seemed to be also a focus on methodological rigor, which is by itself something good, of course. However, it seems to come often at the expense of simplicity and practicability. For example, the risk of bias 2.0 tool, many people think that it is has non-intuitively labeled domains. There are many signaling questions. There's also quite new terminology, which is not easy to understand, in particular for junior systematic reviewers. So there is this quote here, the deviations from the intended intervention that arose because of the trial context. It's not so easy to understand this intuitively. In the literature, you can find studies that associate ROB 2.0 with a low uptake outside of the Cochrane environment, so in non-Cochrane systematic reviews. That misapplication is relatively common and that it has a quite low inter-rater reliability. So that's why we thought, okay, although it is quite an effort, we said, why not develop then a more simply structured, user-friendly instrument, still using rigorous methodology for assessing risk of bias of randomized controlled trials in systematic reviews. And what we have done maybe differently from other risk of bias tool developments is that the available of the information that is required to make judgments about risk of bias was also explicitly part of our item selection criteria, and also the ease of judgment for junior systematic reviewers was also taken into account. So to give you an overview of the instrument development, so first we assembled the panel. Basically, the study was initiated by a team from McMaster University, mainly Gordon Guyett and Ying Wang. And then it became an international collaboration. So there were 16 methodologists and 3 EBM educators from altogether 12 countries. So I was also a panel member here. And the criteria for selecting the methodologists were basically that they had a first or last or corresponding authorship on a risk of bias methodological paper, and also to be a co-author on at least 2 other risk of bias methodology papers. ground rules for instrument development that we set out were that the risk of bias assessment of RCTs is always in the context of systematic reviews. We only considered parallel randomized controlled trials. So robust RCT does not target cluster or crossover RCTs for now. And the assessors don't need to be experienced in EBM methodology. So it is rather tailored to junior systematic reviewers. Everything is embedded in the grade framework for assessing certainty of evidence. And also we did not consider items for fraud detection. So as a next step, then, once we had assembled the panel, was that we were systematically searching for individual items of risk of bias tools. And so we systematically searched Medline, Embase, Web of Science, and Scopus from January 2010 to October 2021, and identified 17 newly published risk of bias assessment instruments, including 127 unique items. So we excluded 61 items which were clearly not addressing risk of bias, and leaving then 66 items for our classification survey. So panel members then checked each item and eventually rated 20 items to clearly address risk of bias, 11 to not address risk of bias, and for 35 items there was actually substantial disagreement among experts. So the conclusion from this work was that many risk of bias assessment instruments actually include non-risk of bias items, meaning they, rather than address indirectness or applicability, for example. And for many items, experts disagree. So it's often not a clear-cut decision making here. As a further step, we then wanted to update the evidence base for effects of potential biases on effect estimates. So we systematically searched for meta-epidemiological studies that looked at different risk of bias items and checked then whether there were any quantification associated with specific risks of bias in terms of impact on the effect estimate. So we again systematically searched Medline, Embase, Web of Science, and the Cochrane database of systematic reviews from this time 2015 up to January 2023. Here we identified 41 meta-epidemiological studies, and we found that failure to ensure random sequence generation or allocation concealment resulted overall in modest overestimation of effects. Lack of patient blinding led to substantial overestimates for patient-reported outcomes. So this can be shown with empirical data. Lack of blinding of outcome assessors results in substantial effect overestimation for subjective outcomes. And trials stopped early for benefit probably overestimates effects. And trials with imbalanced co-interventions also may overestimate effects. Otherwise, the impact on the effect estimate was quite uncertain. So for other risk of bias items. So based on these two preparatory studies, we then started our panel meetings. So overall, we held 16 1.5 hour panel meetings to complete item selection, to complete the instructions for included items, and also to decide about how to present the instrument. So to give you now insights into the item selection process, I would like to show you a couple of overviews. I'm sorry that this is a bit of a crowded slide, but I will just guide you through it. So this is basically the first batch of items. We call it category 1, where the majority of experts agreed, yes, this is indeed addressing a risk of bias. And there were items like here on the left, random sequence generation, allocation concealment, blinding of participants, blinding of healthcare providers, blinding of data collectors, blinding of outcome assessors. And then we had our item selection criteria. So clearly risk of bias rather than other domains that can be found, for example, in grade. We checked whether there's theoretical or logical arguments for why the item is important. And then we also judged whether there is typically information available that is required to make a judgment in reported trials, whether non-expert reviewers can make this judgment easily, and whether the problem is actually quite common or whether it's rather rare. And also we considered then the empirical evidence from the paper that I've just shown you, whether there is any empirical evidence on an impact on the effect estimates. And based on that, we took a decision. So, for example, about random sequence generation, we said, yes, include as core item 1. Allocation concealment, include as core item 2, and so on. For example, then blinding of data collectors here, although we said it is addressing risk of bias, there are theoretical arguments. However, this information is rarely provided. And also non-expert reviewers might have trouble judging that. And also there is basically no empirical evidence about this, led to our decision that we excluded this item, for example, from the final tool. So our category 2 included items where the majority of experts judged that it's actually not addressing risk of bias. These are items such as whether the outcome measure was reliable. So this many experts thought is rather addressing imprecision than risk of bias, or whether the follow-up time was adequate to identify the outcome of interest. That's more indirectness than risk of bias. Whether the sample size was big enough. It's also rather imprecision, and that's why we excluded basically all of these items eventually. So table 3 then took care of all the items where there was substantial disagreement, and so also the final decisions varied quite a bit. There were items such as whether the baseline prognostic factors were balanced between groups. So there were some pros and cons, and we said, however, if it occurs, then it has large or let's say important consequences. Therefore, we would include this as an optional item. I'll get to that later, what optional items are. And similar about co-interventions, whether they were balanced between groups. This is often hard to get this information. It's often not reported. It's not easy to judge. How often this problem actually occurs is not clear. And therefore, we said also include as an optional item too. And for example, here, whether the interventions were implemented as intended, there we decided not to consider that in our risk of bias tool. So this is basically the item selection process. We also then constructed instructions for the included items, and we decided about the final structure, and then did a user testing involving 15 junior systematic reviewers and 8 review experts who actually applied the tool then to a series of randomized controlled trials included in systematic reviews. And so these parts then formed the basis for our article publication of the robust RCT development. And the user testing basically confirmed the simplicity and ease of practical application. And we also found that junior systematic reviewers were indeed able to correctly apply the tool to the RCTs that we had given them. So we still made adjustments. There were a couple of smaller items that we had to adjust. And then we have basically 2 layouts at the moment. So there is a PDF available. So this is a screenshot here, just where you state then the outcome of a included trial, for example. And then it depends really on the items, whether you should do the risk of bias assessment only once for all outcomes. So for example, for random sequence generation and allocation concealment, typically that's the same for all outcomes. So it has to be only done once for an RCT. However, when it gets to blinding of participants, blinding of healthcare providers, or further down, also blinding of outcome assessors, it really can depend on the outcome. So it might be useful then to rate the risk of bias for separate outcomes here. So now the overview of the core outcomes and the process, which always includes 2 steps. So I will start with the first 5 core items. There are 6 in total, and the first 5 include random sequence generation, allocation concealment, blinding of participants, blinding of healthcare providers, and blinding of outcome assessors. I mean, you as Cochrane members probably see the similarity between also risk of bias tool 1.0. And so many people are quite familiar with that. And then we have these 2 steps. So in the first step, we just evaluate what actually happened. So without yet judging the risk of bias, it is just whether the allocation sequence was adequately generated, whether the allocation was concealed, participants blinded, healthcare providers blinded, etc. And then we rate each of these response options in step 1 as definitely yes, probably no, definitely no. And then for the risk of bias judgment, it is then based on the information from step 1. It can be then a more experienced systematic reviewer, for example. The review leader, for example, can then assess the risk of bias. Or if it's an experienced person anyways, then this person can do both steps basically in one go. Or a junior systematic reviewer basically evaluates step 1, and then a more senior systematic reviewer makes the decision in step 2. So these are two approaches. Then we come to item 6. There it is about outcome data that is not included in the analysis. So this can be because there are actually participants lost to follow-up, so that they don't have outcome data contributing to the analysis, or that the authors of a trial decide not to include outcome data from participants in the analysis because they are, for example, focusing on only patients or participants who adhere to the protocol. And so there is also then a number of participants probably excluded then from the analysis. Again, so there are these two steps. So what happened actually is, so just extract the actual number of participants that were not included in the analysis as far as this is available, and then make a judgment about the risk of bias. But here, for this specific item, there are we see two approaches that are possible. So as I said just now, so that you estimate it then, okay, how often is, for example, the outcome in general, the prevalence, and how many participants were actually lost to follow up, and see whether there is then a danger that the number of missing outcome data is even larger than the prevalence of the outcome. Or you could take this approach where you basically look at all the missing outcome data in all of the meta-analysis, and once conduct a complete case analysis, and then you conduct an analysis using, for example, multiple imputation, and you can then also assess whether this makes a larger difference. And for this step, then only, or for this approach, only step 1 is actually necessary. All right, so here an example using item 4, so blinding of healthcare providers. So there are these 4 response options. We are still step 1, definitely yes, probably no, definitely no. So for the definitely answers, we want explicit statements. So an explicit statement that healthcare providers were blinded, or an explicit statement that they were not blinded, or that the trial is open label or unblinded. Then we would say we know what happened. Otherwise, there is some judgment involved. If it is a placebo-controlled trial, we would still assume that this means that healthcare providers are then blinded, and we would then rate this as probably yes. On the other hand, if we do not have any clues like placebo-controlled or double dummy or double blind, triple blind, anything like that, then we would probably say rather probably no. Also with single blinded, if it is more likely that this single blinded concerns another group than the healthcare providers, then you would also go with probably no here. Then step 2 is then to judge whether there actually is a risk of bias, whether this is definitely low or definitely high, probably low, probably high. So if healthcare providers were definitely blinded, we would go with definitely low. If they were probably blinded or the unblinding would actually not matter for the outcome, then the risk is still probably low, and then accordingly here you would then rate with probably high if you have other conditions that are met. If in doubt, you can always go to the manual, which is provided in Appendix 6 of the BMJ publication. Here, the example, blinding of healthcare providers, probably high. We typically give here an explanation so that there is no explicit statement, and that there is a potential that the outcome is then influenced by this unblinded situation. An example is a randomized trial, open label, compared remdesivir and standard of care versus a standard of care alone in patients, hospitalized patients with COVID-19. And one of the important outcomes was duration of hospital stay. And then it could be assumed that in this open label trial, where healthcare providers were definitely not blinded, that this could have an influence on the healthcare provider's decision about how long to keep these patients in the hospital, and therefore we could rate this as probably high because there is a potential influence here. So these were the core items, and then we have an additional 8 optional items, which don't have to be considered. It's optional because either the information for the judgment for these items is very often not provided, so it is very difficult to judge, or that problems with these items are very infrequent, or both. Example, you remember from previously maybe whether baseline prognostic factors were balanced between groups. This is very often the case that it's balanced, so this problem is probably rather infrequent. However, if it occurs that there is really a serious imbalance that also a, let's say, junior systematic reviewer can spot, then one should not ignore this fact, but take this into account. But it's really up to the review leader to check carefully upfront which of these optional items are relevant for a specific systematic review, and then give the instructions accordingly to the junior systematic reviewers when and how these optional items should be considered. All right. I will sum up now my talk so that the simplicity and practicability should be considered when developing risk of bias tools. This is something that was our intention with robust RCT. We think that we used rigorous methodology to develop this tool, and it consists of 6 core items. These 8 optional items, there are always 2 steps involved. Step 1 that can always be done also by junior systematic reviewers for the risk of bias judgment. It might need also then experienced reviewer, and we extensively pre-tested the tool in our usability testing. What we have not done yet is to do any inter-rater reliability testing. Once you have tried robust RCT, please provide feedback. We are very grateful. Here is the email address of Ying Wang. Thank you very much for your attention, and I'm very happy to take any questions now.